So in the last slide we have seen that dou u by dou x and dou u by dou y is equal to the Jacobian inverse dou u by dou zeta dou u by dou eta, where Jacobian we have defined that x13 y13 x23 y23. Now let us rewrite this one. So the Jacobian inverse can be written as 1 of det of j, 1 of det of j, and cofactor of j. The cofactor of j nothing but it can be written as y23 minus of y13 and minus of x23, and here it is equal to x13. So this is a cofactor of j into dou u by dou zeta. Here dou u by dou zeta we have defined that it is equal to u13, that is nothing but it is equal to the u1 minus u3. Similarly, the dou u by dou eta we have defined that it is equal to dou u by dou eta is defined as u2 minus u3, u2 minus u3. So therefore the dou u by dou x and dou u by dou y can be defined as it is equal to the 1 by det of j into, you have to multiply this row into column. So therefore you are going to get that y of 2 3, this row, into u of 1 3, and next two element would be the minus into plus minus y of 1 3 into this u of 2 minus u3 can be written as u of 2 3. Then next one would be the next row into this column, that can be written as minus x of 2 3 into u of 1 3. The next element would be the plus x of 1 3 into u 2 3. So this would be the very important. So now it is possible to say that dou u by dou x, dou u by dou y. So now from this equation it is possible to say that the dou u by dou x can be equal to the 1 by det j y23 u13 minus u1 y13 u23. Similarly, dou u by dou y can be written as 1 by det j into minus of x23 into u13 plus x13 u23. Now similarly it is possible to write as dou v by dou x and dou v by dou y. So by using the above equation I am going to write down that directly it can be written as 1 by det of j, 1 by det of j, and it is equal to the y23, and here u of 1 3 becomes that it is equal to v of 1 3. Wherever u is there you have to replace with the v. So that is the only thing. Okay, so therefore it is equal to v13 minus of, it becomes our y13 into v23, and next element would be the minus of x23 into v13 plus x13 into v23. So see here, if you observe that the above equation and this equation, only the u here dou by dou x of u, but here dou by dou x of v. So wherever the u terms are there you have to replace with the v. That's the only thing. So once you get this one, dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y values, then it is possible to write down the strain. In a constant strain triangle. So next one would be the strain in a constant strain triangle. So the strain can be write as we have defined in the last class. The strain would be equal to the, it is a epsilon xx and epsilon yy, and last term is a epsilon xy, because after it is a two-dimensional member, and this can be written as the epsilon xx can be written as a dou u by dou x, because in the x direction, and epsilon y can be written as a dou v by dou y, and gamma of xy can be written as dou u by dou y plus dou v by dou x, So this would be the very important one. So now to define this epsilon, okay, to define the epsilon you should write down the what is the dou u by dou x. So if you see here the equation, and let us say this as a equation number 1, and let us say this as equation number 2. So from equation number 1 and 2 it is possible to write as the epsilon can be write as it is equal to the, so the first term is a dou e by dou x. So the dou e by dou x can be write as 1 by det of j, 1 by det of j into dou e by dou x parameters are y23, u13, y13 minus of y13 and u23. So that can be write as here it is equal to the y of 23 u13 minus y13 u23. So this is a dou e by dou x. Similarly, the next one is a dou v by dou y. So here dou v by dou y, that is called last parameter, that is called 1 by det. So let us take 1 by det as a common. Then the next element can be written as a dou v by dou y is equal to 1 by det j of minus of x23 v13 plus x13 v23. So that you have to write here minus of, we can write as minus of x23 v13 plus x13 v23. This is the second element of dv by dy. Next one would be the du by dy or dou u by dou y. So dou u by dou y can be picked up from the equation number 1. That would be the second element, and that must be equal to the 1 by det of j into second row. That is nothing but minus of x of 23 u13 plus x13 u23 plus dou v by dou x. The dou v by dou x can be written as the first element in a second equation. The first element in the second equation 1 by det of and this first row. So 1 by det j already have taken the common, and plus of y23 into v13 minus of y13 v23. So this is the strain matrix for a constant strain triangle. So now I would like to take this one. I need to write down this into a matrix form. So if you write down in a matrix form, therefore epsilon can be written as, already we have taken that 1 by det of j as a common, 1 by det of j as a common, and here if you observe that this is a first row, and this is the second row, and this would be the third row, combine of from here to here. So in a 3 rows, okay, we need to write down a matrix. Okay, so if you observe that in this one there would be a displacements of u's as well as v's. Okay, so here u13 can be write as, I'm going to rewrite the above equation again to simplify the matrix form. So y23 can be write as, it is equal to the again y23, and u13 can be written as u1 minus u3 minus of y13, u23 can be written as u2 minus u3 for simplify purpose. This is the first row, and coming to the second row it can be written as minus of x of 23 into v13, means that v1 minus v3, and plus x13 into v23 can be written as v2 minus v3. This is a second row, and third row can be written as x of minus of x of 23, u13 can be written as u1 minus u3 plus x13 into u23 can be written as u2 minus u3 plus y23 into v13 can be written as v1 minus v3, and the last parameter y13 into v23 can be written as v2 minus v3. So here 3 rows are there, and 3 rows and only one column is there. 3 rows and only one column is there. This is the first row, and this is the second row, and the last parameter that this is become that the third row, and only one column. Now this you need to write down in a matrix form. So 1 by det j is common. So if you see here u1 u3 u2 u3 v1 v3 and v2 v3, u1 u3 u2 u3 and v1 v3 v2 v3, means that there is a nodal displacement. If you have taken that the simple CST element, the CST element having a nodal displacement parameter. At nodal number 1, it has a x directional displacement, that is called u1, and y direction is called v1. Similarly, at nodal point 2, it has a u2 and v2. Similarly, at nodal point 3, it has a u3 and v3. So now, therefore, it is possible to take a v1, u1, v1, u2, v2, and u3, v3 as a column matrix. This is say that nodal displacement matrix. If you have taken from this above one, therefore it is possible to write down another matrix. See here. So here I have taken that the nodal parameter as a column matrix. If you see here, this is only one column and it is equal to the 6 rows. So therefore it is a 6 by 1. But if you see that the epsilon would be it is only one column and the 3 rows, 3 by 1. So you must be get that once you multiply the 6 by 1 into this matrix, you must be get the 3 by 1. Okay, so that let us see. So to get the 3 by 1, this must be equal to the 3 by 6 matrix, means that 3 rows and 6 columns. So I would like to write down straight away here that whenever you get the free time, you can take this matrix and separate the u1 and v1s, u2, v2 and u3, v3. Then rewrite this another matrix. Therefore, you will get the matrix. So I am going to write down this matrix straight away. So means that you are going to get the 6 columns and 3 rows. Then first column, first row I am going to write down that is called y23 and 0 minus of y23 0, and next one is a y23 y13 y23 y13. So this is the in between there is a plus and this is a minus sign, and last column would be the 0. So means that 1 2 3 4 5 6 columns are existed. Then second row can be written as it is equal to the first element would be the 0, and second element would be the x of 2 3, and third element would be the 0, and fourth element would be the x of 1 3, and fifth element would be the 0, and last element would be the x 2 3 minus x 1 3. Okay, then the next row can be written as minus of x of 2 3 and y23 and x of 13 minus of y of 13, and the next one is x23 minus x of 13. Then last element I would like to write down here due to the space restriction. The last element y of 23 plus y of 13. So these are the 3 rows and 6 columns. This is a matrix. Now it is a time to define that. This would be written as the epsilon can be written as in the form of the b versus nodal displacement. Let us say nodal displacement matrix would be the u. Okay, so here the B matrix can be written as 1 by det of this matrix. 1 by det of this matrix. So I am going to write down that once you done this simplification, straight away I am going to write down that the B matrix here. So the B matrix or epsilon can be written as B comma U matrix. So therefore here B matrix can be written as 1 by det of J into, after simplifying this, y23 0, and here y of 13 and 0, and y of 12 0, and 0, and here x of 32 0, and x of 13 0, x of 2 1, and the last one would be the minus of x of 2 3 and y of 2 3, x of 1 3 and y of 3 1, and x of 2 1 and y of 1 2. So this would be the B matrix. This would be the B matrix. So now, if you observe this B matrix in a CST triangle, how we are going to calculate the B matrix? If you know that nodal 1 x1 y1 and similarly nodal 2 parameters are x2 y2 and nodal 3 parameters are x3 y3. If you know this one, it is possible to calculate the B. Why? Because the data of j, the j is also can be defined as x of 1 3 y of 1 3 x of 2 3 and y of 2 3. This is a Jacobian. So data of j is also possible to calculate if you know that each and every coordinate values of your CST triangle. So if you know that the nodal coordinates as well as nodal displacement, it is very easy to solve the strain, that is called B comma Q, B comma U, B comma U. So now